So it's time for us to transition now to the first of our market-ready presenters. And Andy, can you get me down to these slides? And panel, stick around. And Abigail from Xylem, if you would turn your camera on now. And I'm having problems with my little chroma key. I'm going to go away and come back in just a minute. But panel, you've had a look at what Abigail is going to be presenting to us. Do you have any specific questions for her or things that you want to make sure that she covers in her remarks? Panel. Andy, you're muted, so can you unmute, please?
Yep, thanks. Question for Abigail. I know we're going to be talking about layers of the technology. Is there a point at which we're beating up too much on the wastewater? You could address that during the course of the conversation.
Okay, Eric, do you have any questions for her?
I think Abigail will be interested from the audience to hear about the integrity process integrated whole wastewater reuse project.
And Joe?
Well, everything boils down to cost and quality, so I'm curious about how the technology costs compare with alternatives.
Okay, Abigail, anything you want to say to the panel before we launch your slides for you?
Well, good morning. I appreciate being invited to this event, and you've got a great panel assembled here. I've had the pleasure of working with a few of your panelists for a few years now. In terms of anything I'd like to say to the panel, I think hopefully between the content that I have and being able to throw in some additional commentary, I'll be able to address the questions you mentioned. I appreciate you setting up the discussion. I agree with some of the comments that were made about where water reuse is right now and where it's moving in the future. I will speak, I think, on behalf of Andy Shea and myself that we're very excited about the focus on industrial reuse. He and I both have a lot of work in there, and I think that's another area that we are really looking forward to continuing to help facilitate development and support projects where it makes sense both technologically and also commercially.
Great. Well, let's launch your slides and get you going. And gentlemen, panel, could you turn your cameras off now? And let's give the show over to Abby. Gail.
Thanks so much for the introduction. I really appreciate it. So just real quickly, as was mentioned, I'm the Business Development Manager for Water Reuse Projects for Xylem. So for those of you who may not be familiar with who Xylem is, let me give you a quick background because chances are some of you are familiar with some of the brands that are under the Xylem banner. So Xylem is part of the old ITT portfolio. A number of the brands that were purchased for treatment were Sanitaire, Flight, Leopold, Wedeco, and a few years ago, Xylem was actually spun out of ITT as a pure play water business. So that is all Xylem focuses on, is how to transport, treat, and test water. So today I'm going to be talking about our treatment portfolio, which incorporates a number of different solutions that are applicable for industrial water reuse. So we've got everything from biological treatment, which is usually the secondary step in the process. I'm guessing a number of the attendees on the phone today are very familiar with that, probably have biological treatment systems themselves. Talk about some of our filtration and tertiary treatment, and then also talk about how some of the advanced treatments such as disinfection and advanced oxidation is playing into water reuse applications today, and how all of these trains might fit together for meeting certain water quality requirements in the treatment process. So just quickly, I want to cover a little bit about Xylem's approach to fostering water reuse projects. So we have a number of areas. The beauty of Xylem is, as I mentioned, we've got a broad portfolio of technologies. So we've got the process integration expertise to look at an entire wastewater treatment system and figure out what are the best places to either tweak it, whether it be with monitoring devices, testing devices, or with additional treatment processes to help improve the efficiency or to improve the water quality coming out of a wastewater treatment system. So there's a lot of focus right now within Xylem on optimization for existing facilities. And then in addition to that, for facilities that are looking to improve water quality, perhaps for reuse, whether it be for industrial reuse or for reusing water for drinking water supplies, we also have advanced technologies to help foster that as well. A lot of focus right now is on efficiency. I imagine that many of the attendees on the line are looking a lot at efficiency. The water-energy nexus is becoming a big topic right now. So looking at life cycle costs where we can make efficient water treatment processes while minimizing the energy consumption going into treating the water is a key area that Xylem is focused on right now with a lot of our controls and optimization systems. And then when we look at process guarantees, for those of you who are familiar with the brands that we carry, you'll be familiar that they've been around for quite some time, and we've got hundreds and thousands of installations for some of our technologies, both domestically and around the globe. With those installations and that history and expertise comes the ability to give some process guarantees based on what we know from the past and how we're looking at clients' water quality criteria for the future. So I just wanted to set the stage a little bit. I've got two other presenters coming after me who are also talking about treatment technologies. But one thing I wanted to set up for you is just the concept of different ways you can essentially mix and match treatment technologies to come up with a treatment train that's ideally suited for meeting a certain water quality criteria. If we look at the different types of treatment trains for water reuse, we might start with something that would require a lower water quality, so perhaps cooling tower makeup or on-site irrigation. That could be a fairly simple treatment train that would involve secondary treatment, maybe with some biology, some simple filtration, and maybe a little bit of disinfection just to keep any pathogens from occurring in the water quality. As we start to look at industrial reuse, there are a lot of different places that the water can go when it's back on site there. You can start to look at more demanding water quality requirements, such as boiler feed makeup, potentially even process makeup. There are some installations where water reuse is being implemented at food processing facilities where it is actually coming into contact with the food products. So in those cases, they're looking at very advanced treatments that would essentially mimic what a potable reuse scheme would look like, maybe something like at the bottom there where you're incorporating everything from secondary treatment all the way to advanced oxidation and very tight membrane filtration with reverse osmosis. So essentially what I wanted to do in this slide is really set up the conversation as we go through and look at both the technologies that Xylem offers and that my colleagues following after me will talk about as well. That way, the attendees on the line can start to think about how these different technologies might fit into an overall treatment train and also start to think about treating the water for the use that it's intended for. And I'll just pause there. I know Andy Shea had mentioned that one of the things he wanted to touch on is the concept of treating the water for the right quality. One thing to keep in mind for the manufacturers out there is that when you're looking at reuse, sometimes it can be helpful, particularly from a cost-benefit analysis, to really figure out where you want to look at that water and what kind of quality you need. There are some cases where perhaps a more advanced treatment train could be attractive because it might look a little bit more like potable water makeup. But at the end of the day, it might be wise to look at, is potable water quality really required, or is maybe a different water quality needed if it's being used perhaps for process water, wash down, irrigation, or cooling tower makeup. And so I think that's the key when you're working with whether it be technology providers, consulting engineers, or internal staff to really ask the question, are we treating the water to the right standard for the use that is being intended for? So something to also think about as we go through is sometimes it doesn't necessarily need to be the most advanced treatments or the cleanest water, but really just trying to figure out how you target your treatment for the intended end use. So I just want to quickly step through each of the different types of treatments that were on that last slide and talk about where Xylem plays into those facilities as well. So biological treatment is typically considered as secondary treatment in most wastewater facilities. As I mentioned, I am guessing a number of people on the phone have experience either running or designing biological treatment systems. So in this case, it's usually moved for bulk or used for bulk removal of contaminants like organics and nutrients. The best kind of biological treatment process obviously is going to be site-specific depending on what kind of footprint is available, what kind of energy consumption somebody is looking to minimize. and also what kind of downstream and upstream treatment processes they may have. So I've listed a few different types of biological treatment systems over in that left there in those greenish, bluish squares. So you've got everything from pretty traditional activated sludge systems all the way to advanced biological treatment systems such as membrane bioreactors. A couple of things that Xylem offers in this space, we've got the Ichthys Advanced Sequencing Batch Reactor, which is essentially a sequencing batch reactor all done in one basin there that helps to improve or minimize some of the footprint over what traditional SBRs might have. And then in the context of energy efficiency and process optimization, Xylem also has an Oscar Process Performance Optimizer package. Xylem offers a number of control and monitoring systems. And so when we're looking at biological treatment facilities, particularly ones that require aeration that consume energy, this is an interesting available process to look at to consider how those units can be optimized with respect to energy consumption. Tertiary treatment usually involves some sort of filtration or disinfection. Again, this can range from loose membranes like microfiltration membranes or disc filters, and then you might look at either chlorine or ultraviolet light to do some disinfection there. Again, Xylem brings a number of offerings to the table here. We have recently launched the Leopold UltraScreen disc filter that has a very, very long-standing history, particularly in Europe, for industrial applications for solids removal. The Wetico Duron UV system is a brand new offering as well that has been designed really to help minimize operational issues when it comes to cleaning the UV lamps and replacing the UV lamps. We've got our membrane lineup and also some ozone generation systems as well through Wetico. Finally, on the advanced treatment side of things, Xylem offers a couple of advanced facilities. One is, although it's a traditionally used process step, it's ozone plus biologically active filtration, and what Xylem has done with its years of process experience and treatment technology expertise is incorporated those two processes together into a process optimization package. We also have pilot test facilities. We have something called the MyPro pilot test unit that is used for customers to evaluate different types of advanced oxidation. So when people are looking at advanced treatment, it can range from advanced oxidation to reverse osmosis membranes or combinations of these two. And if I could ask, we've got a couple of quick videos that just go through these. If you could cue those, that would be great.
The Leopold Auxilia Ozone-Enhanced Biologically Active Filtration System combines the treatment synergy of ozone oxidation and biologically active filtration into a single process solution. This powerful multi-barrier system reduces pathogens and destroys previously difficult-to-treat contaminants. How does the Auxilia system destroy these contaminants? Wastewater is first dosed with the precise amount of ozone, based on flow rate and water quality, to meet the oxidation demand and the treatment objectives. The ozonated water then flows through a baffled contact chamber, ensuring adequate contact time for the ozone to disinfect the water and oxidize most of the trace organic contaminants. Ozone's powerful oxidation breaks the chemical bonds of pharmaceuticals, industrial chemicals, pesticides, and endocrine disruptors, making these substances biologically degradable. The wastewater, with these partially oxidized organics, is then filtered by a biologically active filtration system using the filter media to support an attached growth biomass. The microorganisms growing within the filter media consume and destroy the organics and oxidation byproducts, removing them from the water stream. The active biomass also reduces the remaining BOD and ammonia, and the filtration process traps total suspended solids, increasing the UV transmittance of the effluent stream. The Auxilia Ozone-Enhanced Biologically Active Filtration System produces a cleaner and safer final effluent, low in total organic carbon and extremely low in turbidity. The system destroys harmful pathogens, leaving no chemical residuals or disinfection byproducts, making the filtered water suitable for many reuse applications, or for discharge into the most sensitive ecosystem. And because contaminants are destroyed and not just concentrated, the backwash stream can be recycled to a plant's headworks or even be processed with solid handling equipment.
MyPro AOP pilot container is very versatile and can be tailored to each project's specific requirements to evaluate a number of different treatment processes.
Xylem's portable container is easy to use, manually or fully automated, with real-time monitoring for your testing needs.
It's got the ability to use ozone, UV, or peroxide, and pretty much any combination of those.
We just make sure that we set all the set points and the doses to where we want them to test what we want, and we can just leave it.
At Xylem, we know that stringent requirements demand wastewater to be free of more pathogens and trace contaminants than ever before. That's why Xylem has created this sophisticated pilot test system with the most advanced water treatment technologies available today, all in one container.
The MyPro AOP pilot container is valuable for the customer because it allows them to quickly and efficiently evaluate multiple treatment processes within one system.
All right, thanks for rolling those videos. Can everyone hear me back again?
Yeah, we got you. Some of our presenters need to mute their, or I think it went away. Fine. There was an echo, but we're fine. Go ahead, Abigail.
Perfect. One of the things that I believe was raised from the panelists when we started this discussion was a comparison of treatment costs. And while it's a little bit hard to talk specifics without having a specific project in mind, I did want to cover the comparison between, for example, some biological treatment processes and oxidation technologies, and we're looking at things like footprint, installation costs, and operating costs. So this table just really gives a relative idea of where all those different technologies sit and other considerations to give when manufacturers are thinking about installing different types of processes. I did want to run through a few case studies where Xylem has implemented some industrial water reuse facilities. The first one is a raisin producer. So this one was producing wastewater that had a lot of dust, sugar, and other contaminants from the raisins. They were looking at transportation costs around $50,000 per month to a municipal treatment plant. And one of the things they wanted to do was look at reusing that wastewater. What they decided to do was install a membrane filtration system to clean the water and then reuse it for washing or irrigating in the nearby vineyards. In order to do this, they used membranes from membrane specialists, and then Xylem helped support the project by fitting out the membrane modules with tubular reverse osmosis membranes. The really great thing about this project from a financial standpoint is that it was able to decrease their sewer bills about $300,000 per year, which gave them a return on investment of just under 3 years, which is pretty good for industrial reuse projects. So that's just one example of where some membranes have been used in a food manufacturing facility. The next one I want to talk about is a pharmaceutical plant actually over in Ireland. This one had some active pharmaceutical ingredients from the manufacturing process, which, as you can imagine, are fairly exotic and can be difficult to remove or deactivate. The manufacturer decided that they wanted to introduce some additional good corporate citizenship and improve their sustainability goals by doing a water reuse project. They did bench and pilot scale testing to evaluate what technologies they wanted to use and finally settled on using a combination of membrane bioreactor plus ozone oxidation to destroy the advanced pharmaceutical ingredients and help protect the environment. This one has been online since 2005 and has been used for cooling tower makeup. The final one is in Silicon Valley. It is operated by the Santa Clara Valley Water District in San Jose, and although this is a municipal treatment plant, they send a lot of their water to the local high-tech industries in the valley there to be used for irrigation, cooling tower makeup, and a number of other non-potable processes. This uses microfiltration, reverse osmosis, and UV systems provided by Xylem to help treat the wastewater. So finally, what Xylem is offering to bring to the table to help industrial manufacturers is really a partner to doing the treatability testing all the way from installation and selection to aftermarket. As I mentioned, we have a number of installations both domestically and across the globe to help with our expertise. We can provide a single source of support with the variety of treatment technologies and monitoring equipment that we offer, as well as process performance guarantees and aftermarket services. So that's all I had on what Xylem brings to the table, and again, just kind of setting the stage for the different types of technologies. And I will turn it back over, and we'll move on. Thank you.
Thank you. And panel, can you join us again, please? Thanks, Abigail. Stick around. We're going to ask the panel. Panel, while we're waiting for your cameras to show up, well, there you are. So Eric, why don't you lead off? Any questions or concerns for Abigail? Oh, we need you to turn on your microphone, Eric, sorry.
Sorry about that. All right, so quickly, the Abigail, nice presentation. You point out a very good point about when you try to do the reuse project, sometimes not just rely on one single technology. You got to combine two very different processes, integrate together. So I appreciate you present that. So Abigail, from your slide there, if you have any particular experience you can share with the audience, such like the food and beverage industry.
Sure. So for food and beverage, a lot of times biological treatment processes are very effective for the high BOD that you might find and the COD that you might find in manufacturing. Typically, you'll need a solids removal step as well, so it could be a filter. They could use chemical precipitation. And then depending on what the intent is, again, for reuse, if it's going to potentially cooling tower makeup, that could be sufficient. If there is a need for the water to be used in a contact operation, then looking at some advanced treatment, potentially some tight membranes or advanced oxidation might be worthwhile to help clean that water up a bit more and get it to a point where it doesn't impact the actual quality of the food processing.
Thank you.
Thanks, Eric.
So Andy, what questions do you have for Abigail?
Well, I think some of the questions that are flying on the screen relate to direct on-site use by the industrial versus off-site. Abigail, with respect to municipally supplied wastewater to high purity uses, do you see a relative split in the applications from Xylem's standpoint?
Sure. So I think the question was really, how does on-site treatment differ from if an industrial facility is taking water from a municipality? Is that correct, Andy? Did I interpret that right?
Yeah, just from an application standpoint.
Sure. Well, it's interesting because depending on the municipality and the kind of partnership that they might have with the local manufacturers, some municipalities, there are some in California, where they essentially have designer water, where they have more or less sectioned out their wastewater streams and treat it to different levels to go to different types of industrial facilities. So it might be, a simple secondary treatment with filtration if it's going to cooling tower makeup versus if it's going to a refinery for boiler feed, they might add some advanced treatment with nanofiltration or reverse osmosis membranes. So a lot of that has to do with what I would say local relationships and public-private partnerships, whereas on-site treatment, manufacturers can typically make, I think, a more deliberate decision on what kind of treatment they want to employ. And one thing that on-site manufacturers can also consider if they're doing reuse is whether or not they would like to treat a bulk wastewater stream coming out of all of their processes from the manufacturing plant, or if they would like to consider treating wastewater coming off of each individual process where it is generated and doing that point source treatment as well. So it's a little bit of a vague answer because it's not a specific site, but the nice thing is, I think, for industrial manufacturers that there are options out there, whether it's bulk removal at their own facility, coordinating with the utility, or looking at point charge treatment as well within their manufacturing plants.
And Joe, how about you?
I'll just reiterate what Abigail said, that it's really all boils down to fit for purpose. What's the end use of the water? Therefore, what quality do you need to reach? And it isn't very many applications where you must get to extremely high quality, such as close to drinking water, such as if there may be food contact, because most of the other applications are more driven by the end use. For example, if it's cooling water, you don't want to have too many solids in there, or possibilities of scaling and such. So it's all very driven by the end use.
So Abigail, do you have any questions, since these esteemed gentlemen sort of represent the market in total, do you have any questions for the market? Any questions for these folks?
I would have a question about when you are working with clients and you are hearing about projects. One of the things that everyone has to consider, particularly for companies that are looking at having paybacks for shareholders, is what kinds of business cases and business case justifications are you finding help industrial manufacturers move reuse projects through their pipeline?
Gentlemen, any one of you?
I can start a response. I think that the biggest challenge here is the very high hurdle rates from the number of our clients from that's food and beverage, pharmaceutical, chemical, and as we all know, utilities are usually kind of low on that funding list. So how do you, turn a 5 or 7 year return project into 2 or 3? Typically, we recommend stepping through a sustainable return on investment analysis to evaluate the sort of soft costs, the soft benefits, really the avoided cost of water, and then and only then can you really get to that dollar on dollar equivalence analysis.
Eric?
Yes, I also like to advise the client, the people are working with, not just looking for strictly only those water costs or those return on investment or capital costs. You also need to think about ahead. Sometimes if you don't do this, what's my business risk? What's going to impact to the future operation? So those kind of future costs may be difficult to quantify, but I think you need to be put into part of the equation.
Joe?
Thank you.
Oh, I generally deal with municipalities, and their cost isn't that significant. Orange County spent $450 million on their recycle application. So it's all a matter of public acceptance. If the public goes along with it, if they're willing to pay the bill, then it goes.
Well, let me ask the question just as a generalist again. And this was one of the questions we had pre-planned to ask the panel. Can we repeat what we just said in super duper shorthand for senior managers who are not subject matter experts? So you're pushed in front of the board and you have 15 seconds and you're going to tell them, here's when it's time to do this and here's how you make sense of it. What's the answer? What's the 15-second nugget?
I would say it's what are your water needs? What is your accessibility? Can you meet those needs? And how much are you willing to pay?
Okay. Andy, Eric, do you have another take on that?
I think it's very binary. Nobody knows the value of water until the well runs dry, and in a lot of cases, you've got to plan for it in advance.
Eric?
I think water is such essential to the business. Can you ask in the upper management, say, prepare for the case if we don't have water tomorrow? What are we going to do?
Okay. So you guys do pretty well in front of the board, it sounds like. Abigail, did they answer your question for you?
Absolutely. I appreciate the comments from everyone and the different perspectives. I think that's great, and hopefully it's helpful to the attendees on the line, too, who might be thinking about, well, if I want to implement a reuse project, what do I need to be thinking of from a business case perspective to start maybe drawing the box a little bit broader than just the water piece, but again, the risk of what happens if it's not there and how you incorporate some of the other benefits of reuse projects. So I appreciate the feedback, and hopefully the people on the line also found it useful.
Speaking of the people on the line, have we addressed all the questions that were in chat? I said we're just taking, hold on audience, we're just sort of scanning. Abigail, is there anything in there that you'd like to address, or did we already cover it?
I think we've probably covered most of them. I do see one sitting in here that asks a question about FDA-approved reuse of treated pharmaceutical industrial wastewater. This is one of those things I think, and I can't necessarily speak on behalf of the FDA, one of the interesting things when it comes to reuse regulations, and the panel might be able to speak to this too, is that they are very state-specific. They're very regional specific. I know that they differ even from Colorado to California to Texas about, from a non-potable perspective, how water can be reused. I know in the case of food and beverage manufacturing, a couple of the facilities where the water has been reused for direct product contact, the project have essentially built a treatment plant to produce drinking water, so that they essentially ended up avoiding the whole question of where does it fall into the reuse regulations, because they were producing drinking water. So those are the things that I know of. Some of it is state dependent regarding what the approved uses are, what the water quality requirements are for different categories of reuse water. But then also other people have gotten kind of avoided the whole discussion about the reuse regs by just building potable water treatment plants at their industrial facilities.
Great. Okay, well, we have to do a time check here. And panel, that's a great topic for future discussion, but we are out of time right now. We have to do, actually, buzzers are going off in my ear telling me it's time for us to go. Abigail, thanks. That was magnificent.